Hello everyone, I'm Dr. Janavi Chakrabarty, Assistant Professor, Department of Mathematics, Bardhaman College of Engineering. Today in this video, I'm going to explain the Simpson's 3/8 rule. Now let us see what is Simpson's 3/8 rule. Simpson's 3/8 rule for estimating the definite integrals of the form I equal to integration a to b f of x dx uses 4 equally spaced points. As we know already that definite integrals means it is the area under the curve between 2 points, right? This is the graph for integration a to b f of x dx. Now in Simpson's 3/8 rule, what we do, we will divide this interval a comma b into n sub-intervals. Here I am taking one example with 4 points which are x0, x1, x2, x3, and here we have 3 sub-intervals which are x0, x1, x1, x2, x2, x3, and each of which h. Now as here n equal to 3, so the integrand is approximated by third order polynomial or cubic polynomial, and the number of sub-intervals in Simpson's 3/8 rule must be multiple of 3. The sub-intervals can be 3, can be 6, can be 9, and so on. The Simpson 3/8 rule, we can obtain it from Newton-Cotes quadrature formula by putting n equal to 3 in it. So here is the Newton-Cotes quadrature formula which is given by this. Here if we put n equal to 3, we will get the Simpson's 3/8 rule which is given by integration x0 to xn f of x dx is equal to 3h by 8 y0 plus yn plus 3 into y1 plus y2 plus y5 plus so on plus yn minus 1 plus 2 into y3 plus y6 plus y9 plus so on yn. These are multiples of 3. So you can say this is 3h by a first term plus last term plus 2 into terms which are multiple of 3 plus 3 into remaining terms. Now let us see how we can derive Simpson's 3/8 rule from Newton-Cotes quadrature formula. First of all, let us write the Newton-Cotes quadrature formula. By Newton-Cotes quadrature formula, we have integration x0 to xn f of x dx is equal to nh y0 plus n by 2 first forward difference of y0 plus n by 12 2n minus 3 second forward difference of y0 plus n by 24 n minus 2 whole square third forward difference of y0 plus so on. This is equation number 1. Now we will put n equal to 3 in equation number 1. N equal to 3 means we have 4 data points. N equal to 3, this means we have x0, x1, x2, x3. Corresponding y values will be y0, y1, y2, y3. First forward differences will be first forward difference of y0, first forward difference of y1, first forward difference of y2. And second forward difference will be second forward difference of y0, second forward difference of y1, and next we will get third forward difference of y0, and all higher order differences will be 0. Therefore now we will be taking the curve y equal to f of x through the points x0, y0, x1, y1, x2, y2 and x4 as a polynomial of third order, so that higher order differences will be 0. That is fourth forward difference onwards it will be 0. Now as we are going to put 3 here, 1 becomes integration x0 to x3 f of x dx which will be equal to nh, that means 3h, y0 plus n by 2, 3 by 2 first forward difference of y0 plus n by 12, 3 by 12, 2n minus 3, 2 into 3 minus 3, second forward difference of y0 plus n by 24, 3 by 24, n minus 2, 3 minus 2 whole square, third forward difference of y0. So we will get 3h y0 plus 3 by 2 first forward difference of y0 plus 3 by 4 second forward difference of y0 plus 1 by 8 third forward difference of y0, which is equal to 3h y0 plus 3 by 2. This one we can write it as y1 minus y0 plus 3 by 4 y2 minus 2y1 plus y0 plus 1 by 8 3y3 minus 3y2 plus 3y1 minus y0. If we take 1 by 8 outside, then we will get 3h by 8, 8y0 plus this will be 12 y1 minus y0 plus 6 y2 minus 2y1 plus y0 plus y3 minus 3y2 plus 3y1 minus y0. This will be 3h by 8, 8y0 plus 12y1 minus 12y0 plus 6y2 minus 12y1 plus 6y0 plus y3 minus 3y2 plus 3y1 minus y0. Now what we will get? 3h by 8, 8y0, 12y0, 6y0 and y0. So from these terms we will get only y0 plus these two will be cancelled out. 3y1 plus 3y2 plus y3. So this is what we are getting for x0 to x3 f of x dx. Similarly, we get integration x3 to x6 f of x dx is equal to 3h by 8 y3 plus 3y4 plus 3y5 plus y6. x6 to x9 we will get f of x dx is equal to 3h by 8 y6 plus 3y7 plus 3y8 plus y9 and so on. X n minus 3 to xn f of x dx is equal to 3h by 8 y n minus 3 plus 3y n minus 2 plus 3y n minus 1 plus yn. As integrals are additive over subintervals, so adding all these integrals we will get integration x0 to x3 f of x dx plus integration x3 to x6 f of x dx plus x6 to x9 f of x dx plus so on plus integration xn minus 3 to xn f of x dx is equal to, we will add all these terms. 3h by 8 will be common, then we will get y0 plus 3y1 plus 3y2 plus y3 plus y3 plus 3y4 plus 3y5 plus y6 plus y6 plus 3y7 plus 3y8 plus y9 plus so on plus last term will be yn minus 3 plus 3yn minus 2 plus 3yn minus 1 plus yn. Now look at this side. This side we can write it as integration x0 to xn f of x dx, which is equal to 3h by 8 first term plus last term plus 3 into y1 plus y2 plus y4 plus y5 plus y7 plus y8 plus so on yn minus 2 plus yn minus 1 plus 2 into y3 plus y6 plus y9 plus so on yn, which is the required Simpson's 3/8 rule. Now let us evaluate definite integrals using Simpson's 3/8 rule. Look at this problem. We need to evaluate integration 0 to 1 root over 1 plus x power 4 dx using Simpson's 3/8 rule. Here, number of subintervals is not mentioned. Also, width of the interval is not mentioned. As we know, the Simpson's 3/8 rule is applicable only when the number of subintervals is multiple of 3. Here, a equal to 0, b equal to 1. Let us divide interval 0, 1 into n equal to 6 subintervals. 6 is multiple of 3. Therefore, h equal to b minus a by n, 1 minus 0, 1 minus 0 by 6, 1 by 6. Also, y equal to f of x, that is given as 1 plus x power 4. Now we will make one table for x and y values. The x and y equal to f of x values are given below. First value of x is 0. Next value will be 1 by 6, 2 by 6, 3 by 6, 4 by 6, 5 by 6 and 6 by 6, which is equal to 1. This is x0, x1, x2, x3, x4, x5 and x6. If x is 0, then y will be 1. And for these values, we can use calculator, and this will be this. This is y0, y1, y2, y3, y4, y5 and y6. Let us substitute these values in Simpson's 3/8 rule. Therefore, by Simpson's 3/8 rule, we have integration x0 to xn f of x dx is equal to 3h/8 first term plus last term plus 3 into y1 plus y2 plus y4 plus y5 plus so on yn minus 2 yn minus 1 plus 2 into multiples of 3 y3 plus y6 plus y9 plus so on yn. As we have n equal to 6 here, therefore x0 to x6 f of x dx is equal to 3h/8 y0 plus y6 plus 3 into y1 plus y2 plus y4 plus y5 plus 2 into y3. Now let us put the values. Integration x0 is 0, x6 is 1, f of x dx is equal to h 8 into 6, y0 is 1 plus 1.4142 plus 3 into y1 1.0004 plus y2 is 1.0062 plus y4 is 1.0943 plus 1.2175 plus 2 into y3 is 1.0308. Therefore, integration 0 to 1 root over 1 plus x power 4 dx is equal to, if you compute this in calculator, you will get 1.0894, which is the required answer. Look at this next problem where we need to evaluate integration 0 to 1 1 by 1 plus x dx using Simpson's 3/8 rule. Here also the number of subintervals is not mentioned. Also h is not given. So what we will do, we will divide the interval 0, 1 into 6 subintervals because 6 is multiple of 3 and Simpson 3/8 rule is only applicable when n is multiple of 3. Here a equal to 0, b equal to 1. Let us divide interval 0, 1 into n equal to 6 subintervals, each of which h equal to b minus a by n, 1 minus 0 by 6, 1 by 6 also is equal to 1 by 1 plus x. Now we will make a table for x and y values. The table for x and y equal to f of x values is given below. The x values will be starting from 0, 1 by 6, 2 by 6, 3 by 6, 4 by 6, 5 by 6 and 6 by 6, which is equal to 1. If x is 0, then y will be 1. For these values, we will use calculator and we will get these values. This is y0, this is y1, this is y2, this is y3, y4, y5 and y6. Let us put these values in Simpson's 3/8 rule. Therefore, by Simpson's 3/8 rule, we have integration x0 to x6 f of x dx is equal to 3h/8 y0 plus y6 plus 3 into y1 y2 plus y4 plus y5 plus 2 into y3. Now let us substitute the values. 3 by 8 into 6, h is 1 by 6, y0 is 1 plus y6 is 0.5 plus 3 into y1 0.8571 plus y2 is 0.75 plus y4 is 0.6 plus y5 is 0.5454 plus 2 into y3, which is 0.6666. Therefore, 0 to 1, 1 by 1 plus x dx is equal to, if we compute this using calculator, we will get 0.6932, which is the required answer. And this is how we evaluate definite integrals using Simpson's 3/8 rule. Here, number of subintervals must be multiple of 3. Thank you.